and or exclusive or an implication. So this thing is called truth table. This table is by definition DEF. That means why there's a 1 here, why there's a 0 here is by definition. We don't argue why there's a 1 here, why there's a 0 here. Let's look about n. If P is true, that means there's a 1 here. And if Q is true, then we set P and Q true. If any one of them has a 0, including both of them have a 0, then P and Q is false. Or it's the opposite. If any one of them is true, that means P is true, right? So it's a true. P is true here, right? So it's true. Oh, P is not true, but Q is true. So true. So P or Q is false only if both of them are false. What about exclusive OR? Exclusive OR, you cannot have P and Q at the same time. So if P and Q are both true, you have a false. That's it. P implies Q. If P is true and Q is true, then we say P implies Q is true. Makes sense. If P is true and Q is false, we said P implies Q is false. Makes sense. If P is false, no matter what is Q, we always say it's true. This is ex facto quodlibet. It means if P is false, then it's meaningless to talk about this sentence. And if this sentence is useless, then we want to assign a truth value such that the existence of this sentence do not harm the whole logic system, and therefore we put a 1 here. If P is false, I don't care about what is Q. I automatically say that this is true. If P is false, then it doesn't matter what we discuss, because it's from falsehood, from something wrong. If this is true, wrong implies true does not make sense. Wrong implies wrong also doesn't make sense. So this thing has some problem. But we don't want this kind of sentence to have trouble in the whole logic system. We give them 1. Why give them 1, not 0? Later, I can add a not in front of this whole thing, or I add a tautology in front of this whole thing, or I combine all of them. And if you don't define it like this, you will cause error. So this is the reason why this 2-1 is so special. And now let's look at the detail. So binary operator means we have 2 variables. If they are ternary operator, that means we have 3 statements, PQR. And then as I said, n is like min. So true give us true. It's like 1 min 1 is 1. False true give us false. It's like minimum of 0 and 1 give us 0. What about OR? It's max. False give us false because max of 0 and 0 is 0. Max of 1 is 1. That means true or true is true because this. And here's an important notation. Always put bracket. If you write this, who the heck know you mean not P or Q or P or Q whole thing not. We don't know. So write bracket. Write bracket. Okay? And now here's an example. Suppose I want to solve this problem. P and Q or P and R. So how do you solve it? You have 3 variables. Each variable have true or false 2 possibility. So you have 3 to the power of 2, 8 possibility. Actually, it's 2 to the power of 3, I made a mistake. Then you will have this thing. So how do you start? You first have 3 variables, because you only have true or false, right? So you first start with true, false, and then true, false, true, false, and then true, false. That means what? In the last column, you just write true, false. You start with the third column. And then in the second last, you make it double. And then in the first column, you make it double again. So now you have a bunch of this thing. Then now you fill in this. P and Q is true if both are true. So these are both true, so there's a 1. This is also true, right? So there's a 1. This is 0, 0, so 0, 0. 0, 0, so 0, 0. Both are 0, so 0, 0. Done. And then doing the same thing as an exercise for you, you will get this. So now I have these 2 columns. What is my statement? My statement is this thing or this thing. Then what I do? I will have this thing or this thing. What's the definition of OR? OR is only 0 if both of them are 0. This whole part is 0, right? So everything here is 0. And everything else is 1, 1, 1. That's it. If you understand everything up to here, you already understand everything in chapter 1. What's chapter 1? Basically, is to solve this kind of table. By what? By this. That's it. And then this is a solution of another exercise. So this is an exercise. Solve it in your spare time to test your understanding. Okay? So now let's go to the most exciting thing. P implies Q. And we call this thing implication. This reads as if P then Q. Or you can say P implies Q. Here's an example. If I am a millionaire, then everybody get an A. So P is I am millionaire. Q is everybody get A. As I told you, if P is false, this whole sentence is always correct. This is called ex-faso quarterback. It means anything is true if the starting point is false, because this sentence is rubbish. So this thing is by definition. And then here's another thing. There's no freedom. What does it mean? We are talking about logic. We are not talking about common sense. So if P then Q means that P is true, I must do Q. So here's an example. This statement, logic statement, not common sense, is that if I am a mouse, then I chase cat. That means what? If I am really a mouse, I must chase cat. I have no freedom. I have no free will. Well, common sense is that mouse are afraid of cat. So if I'm a mouse, I should run away. But this is a logic. That means if I'm a mouse, I must do Q. So in logic, P implies Q means if P, then must Q. There's no freedom. This is different from common sense. And then here's a funny thing. These two sentences are equivalent. If I am a millionaire, then everybody get an A. So this is P imply Q. This is not P or Q. And I'm bad, I forgot to write bracket. Okay? So what does it mean? P means I am millionaire, right? Not P means I am not a millionaire. What is Q? Q is just everybody get an A. What's the operator inside? It's logic OR. Okay? Remember, this is and, this is OR. Okay? This is not. Okay? And or not, that's enough. Then what is this sentence? I am not a millionaire or everybody get an A. Logically speaking, they are the same thing. How the heck you prove two sentences are the same? This is what you do. I have P, I have Q. Okay, I need this and this, right? So now I do P and Q and not P or Q. Okay. So if I have P, I can also have not P, right? So now I'm going to do the 1010 thing. So Q is 1010. P is 1100. What's not P? Just flip 0011. Okay, so now I have this. Okay, so now look at this guy. This is OR, right? When we look at OR, we just have 1 as long as anybody of them have 1. So this guy have a 1 in Q, so this is a 1. This guy have 1, so this is a 1. This guy have 1, there's a 1. This is the only guy both have no 1, right? So 0. What about this guy? It's 1011. Why? 1011 by definition. So P implies Q is the same as not P or Q. That means what? That means from now on, whenever you think of a statement, in this case, if P then Q, you can also equivalently think it as not P or Q. Important. Okay? And now here is a bunch of English saying the same thing. So you can say that if they P and Q, basically everybody will just say this. Please just use this. In daily life, some people are such an asshole, they will talk about this to confuse people. Here are example. If happy then fly, happy is H, fly is F, so that means H imply F. Okay? Fly if happy, it's the same. And here are another example. This is very important. Why? Later you will know these two things. If a function is differentiable, it has to be continuous. And if a sequence is monotone and bounded, then it converges. And we will study math at this level. With this, now you can understand why differentiate x squared is x, why 0.999999 until infinite number of 9 is 1. You can use this to argue with people who say that, yeah, 0.999999 infinite number of 9 is 1. If they disagree, then you say you are not logical, get the out, okay? If P then Q is not the same as if Q then P, right? If I am a mouse, then I chase cat. It's different from if I chase cat, I'm a mouse. I can chase cat if I'm a man, right? So this is different, and we give a name called converse. So that means what? You have these following 4 things. Again, these are just name. Knowing the name, useless. Know what they mean, important. This if P then Q is the original statement. If not Q then not P is called the contrapositive. If Q then P is called converse, and if not P then not Q is called inverse. I give you a statement. If n is an even number, then n squared is divisible by 4. Write down its contrapositive. What's that? If n squared cannot be divided by 4, then n is not even. Here are another example. So R means it rains. Rain with a letter R, so I write R. Ground is wet, so W. Okay, and then it is dangerous because the floor is slippery, so I have a D. And I am happy is H. So what the heck is this? This part is this part, right? If it rains, then it means this arrow, ground will be wet. By definition, ground is wet is this, okay? then it is true that if ground is wet, it is dangerous. So, okay, if ground is wet, then it is dangerous. Is this? Ground is wet, it is dangerous. So what about this arrow? This arrow is this then, okay? And then what? Okay, again, we are talking about logic. Of course, normally you won't be happy if you come on, this does not make sense. But I'm now using this as an example. This is a crazy example, so you have strong impression. That means you remember it. Then it's true that I'm happy. Is this part? Okay. I should not use the same color, so I should use green. So this is the then, this is the then, and then I'm happy. I'm happy. If it rains, then the ground will wet. Then it's true that if the ground is wet, it's dangerous, and then I'm happy. First of all, don't talk this kind of sentence to stranger. They think you are mad. This is logic. Okay, logic is not common sense. This is mathematics. Mathematics sometimes doesn't make sense. Okay, therefore, this is just for you to train. And how do you solve this? Do the same stuff as I told you previously. This is an example. You can practice on your own. So you should get this true F thing or 1 and 0. Okay. Another exercise. Give an implication proposition. Okay. If I am a millionaire, everybody get A. Give converse, inverse, contrapositive. If everybody not getting A, that means I'm not a millionaire. Okay. If everybody get A, then I am a millionaire. Inverse. If I am not a millionaire, then everybody will not get an A. Okay. And important, don't forget the if then have no freedom. That means if I am not a millionaire, then everybody not get an A. This is a true statement. Then you must not get A. Okay. Otherwise, the statement is wrong. Okay. Now, what about if and only if? If and only if basically it's just two sentences in one. You have if P then Q and also if Q then P. It's like this. So basically, how do you fix this kind of sentence? It's just you do it 2 times. From this direction and to that direction. That's it. That means the hardest part in the whole session 1 is basically the if P then Q thing. Of course, it assumes you are very good at all these things and or not. So basically, session 1, in summary, what is a proposition? True or false? Nothing else. And then what? And or not. These 3 things. True or false, and or not. This table, third thing, the hardest thing is the if, and these 4 things combined together, you can now have many crazy logic. So this will be my 5th thing. Basically, is you combine all of them. So logic, just these 4 things. Let me repeat. Proposition, and or not, truth table, and the hardest conditional or implication or if P then Q. And the last one is just combine them. Because you see, I'm just combining them. This is just combining them. Okay,